After, we are the group of Bajado, Tukila, and Inere, and we will be presenting a preliminary data analysis for the data entitled The Average Height to Weight Ratio Chart for Adults. So here is a screenshot of said source by disabledworld.com, published in 2017 and updated April of this year. So we only selected the weights from heights 4'6" to 5'10" for both sexes, and for the range of each weight, we use the upper and lower limits to compute for the mean to establish a single generalized central value. So moving on, we can see here the two data value, the mean of the ideal average weight for men and women for a specific height, the height being positioned here at the leftmost column. So first, we found a linearized version of the two data values using scatter plot with an x representing the weight of the females and y being the weight of the males, both in kilograms. So with an r-squared value of 0.99999 and the positive slope of the trend line, we can see a glimpse of how strongly related the two variables are. Then we use the correlation function of XL using equals correl and selecting the two datasets as RA1 and 2. So when we type correl, we choose the RA1 and 2, and we selected this one and this one. So we got our Pearson correlation coefficient, or R, as 0.99999 So since the R is positive and it is very close to 1, we can tell that the two variables are highly correlated and they have a direct relationship. We can also say that as weights of the males increase, the weights of the females also tend to increase, and vice versa. So moving on, we performed the t-test to compare the variance of the two datasets. Take note, we compared the variance. So first, we identified our null and alternative hypothesis. Our null hypothesis is the variance of the weights of the males and females is equal to each other. Then, we also have our alternative hypothesis. So since we will use a two-tailed analysis, as seen here, our alternative hypothesis is the variance of the weights of the males is not equal to the variance of the weights of the females. So for this, we will now utilize the toolpath feature of Excel, so data analysis and all, and select our values with a standard confidence level of 95 and alpha of 0.05. So after all that, we get this set of values. So what we should focus on here is the p-value for two-tailed analysis, as seen here, highlighted in orange. So as we can see, the p-value is greater than our alpha, which means that there is no sufficient evidence to conclude that at alpha 0.05, the weights of the males are significantly variable or different to the weights of the females with heights 4'6" to 5'10". Or in summary, or in other words, we do not reject the null hypothesis because our test statistic lies in the acceptance region. So from this, we can also establish a relationship using regression analysis. So for regression, we will also use the toolpath feature back in the data values. We will use the toolpath feature as we did previously, but we will select regression instead of the t-test. We will then get this set of values. So we get our estimated intercept, negative 6.422, and estimation beta 1 coefficient, 1.1989. So from this, we establish our equation, which is the weight of the male hat is approximately equal to the negative minus 6.42 plus 1.199 weights of females. So we can say that for every 1 kilogram increase in weight of females, the mean weight of males also increases by 1.199 kilograms. So that is all for our data analysis. Thank you for listening and have a great day.